Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating blog post detailing 2 data science projects implemented in the K programming language. It's incredibly efficient and elegant.
I'm really looking forward to this. The K language isn't something I'm super familiar with. What are these projects about?
The first project analyzes the CMU pronouncing dictionary to determine the most common consonants following R and L in English words. This is directly relevant to the author's development of a new shorthand system, Smith shorthand, where the height of certain symbols indicates following consonants. Pretty neat, huh?
Wow, that's a very specific application. How did they approach the problem in K?
The K code is remarkably concise. They first read the dictionary, splitting each line into individual sounds. Then, using some clever array manipulation and Boolean logic, they identify sounds following R or L. Finally, they count the occurrences of each sound and sort them by frequency. The whole thing is, like, 20 lines of code.
Amazing. So what was the result? Did they find to be the most common following consonant?
No. Actually, D was the most frequent consonant following R or L. This is quite insightful for the shorthand system, suggesting that doubly raising the R and L symbols to indicate D would be a highly efficient shorthand convention.
Interesting. I wonder if that holds true across different corpora. Perhaps a larger dataset would yield different results. It's a limitation of the study, right?
You're right to point that out. The data set used is the CMU pronouncing dictionary, which might not perfectly represent all aspects of English pronunciation. A larger, more diverse corpus could indeed provide a more robust analysis. But for the author's specific purpose, it seems sufficient.
I see. So what's the second project?
The second project delves into cricket statistics. Specifically, it aims to identify cricket bowlers with the best average among those with a similar number of wickets. The author uses a dataset of ICC test cricket bowling figures.
Fascinating. That sounds like a complex statistical problem. How did they tackle it in K?
They cleverly used K's array processing capabilities. First, they filtered the data to include only bowlers with at least 1 wicket. Then, they sorted the bowlers by wickets, descending, and average, ascending. This allowed them to identify the bowler with the best average for each wicket count.
Clever. And what did they find?
They identified several bowlers who had better averages than any other bowler with the same or more wickets. They also explored the distribution of wicket counts, finding the most common counts and the smallest gap in wicket counts among the bowlers in the dataset. The code is, again, surprisingly compact and efficient.
Impressive. It really highlights the power of K for data manipulation. This is a great example of how a concise language can lead to elegant and efficient solutions.
Absolutely. Both projects demonstrate the elegance and efficiency of K for data analysis tasks. It's a language worth exploring for those interested in concise and powerful data manipulation. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of K and data science. Goodbye.
Bye-bye.